Object variables can be used in pretty much the same way that any other variables can be used, which means that we can use them in functions. We can pass objects as arguments to parameters that contain a reference to the object. Let's look at two examples. Here we have examples of two functions. We have a function called copy2d, and if we read the precondition, we notice that, so p needs to be a 0.3 object. What does this function do? Well, it's going to make a 2D copy of the point p. That means it's going to be a copy that's going to have all of the same coordinates, except that the z coordinate is going to be 0. All right, so that's one example of a function. But here's another example of a function. And you'll notice a lot of interesting things here, like, well, the specification doesn't start with the word returns. This is actually a procedure. What exactly is going on here? So the issue here is that, okay, we can use objects in functions, but they behave a little weirdly and different than what we've seen before. Let's go to the Python tutor. Let's go first look at this function copy2d. So as we've said, what it's going to do is it's going to return a two-dimensional copy of a point. We're going to visualize this. I'm going to import the module and I'm going to define the function. And now I have created this new point. I have created the point, which is the folder off here to the right, and I've assigned it to the global variable q. And now I'm going to call copy2d on that variable q. This is a function call. It creates a call frame. And when we create a call frame, we immediately create variables for all of the parameters, in this case, the parameter p. And we evaluate the arguments and pass them to the parameters. Now, what does evaluating the argument mean in this case? Well, the argument is q. So what's inside of q? Oh, the name of the folder. So that means the name of the folder is now going to be put inside of the variable p. And if we look at it, the global q and the parameter p both refer to the same folder. Okay, so now we're going to execute this next line of code. And you'll notice what happened here. So inside this line of code, we had a call to another 0.3 constructor. And that's important. The only way that we can make a brand new folder is to call the constructor again. And this time when we called the constructor, we made sure that the z value is 0. Okay, so now what we're going to do is we're going to return that. What are we returning? Well, we're returning the identifier, the name of this new folder that we've created. And now the function is done. So remember, when we're done, we're going to erase the call frame. So every single thing is erased. Oh, except the new folder that I had created, right? And that was pretty good, right? Because the name of that was actually stored inside of the return variable. So now R references this folder. So even though I created a folder inside of a function, normally any work that I do inside of the function is lost when the call frame is erased, but not the folder. And that's because folders and call frames live independently of one another. Just because I erase a call frame does not mean that I erase a folder. And that has a very important ramification. This means that with objects, we can define what are known as mutable functions. A mutable function is a function that alters its arguments. Now, before, we couldn't do that at all, because when we called a function, what happened was it copied the argument's value into the call frame. And so since it was a copy, the original was never affected. Oh, but wait, what's happening now is we're copying the name of the folders, but the folders are never copied. Oh, so we could have a function that could alter a folder. Let's look at an example of a mutable function. This is the second function, which is increment x. And you'll notice that it doesn't have a return value at all. It's a procedure. Look, if we modify the arguments, why do we need to return anything new? It's okay to be a procedure. But let's watch what happens. So I'm going to import intro CS, and I'm going to define the function. And now I'm going to create my point and assign it to p. I'm going to call the function increment x. And notice that I've called it as a procedure here. I'm not trying to assign it to a variable at all. This is going to create a call frame. When I create a call frame, I have created the parameter variable q, and I'm going to copy the argument into q. So now both the global p and the parameter q both refer to the same folder. So now I'm going to say Q, I want to go inside of this folder and increment its X attribute by 1. And now we're done. There's no return value at all because this is a procedure. So I'm going to erase the frame. Everything is lost, but the folder and the changes to the folder still persist. This is a big deal. Mutable functions are going to open up a wider range of options than we've ever had before. And we're going to be seeing these in future assignments.